This is Dave, aka the Guru, and another tutorial on Gamesalad. In this video series, we're going to go through the physics engine and the behaviors associated with the physics engine in Gamesalad. We're going to go through how we use different behaviors and kind of how to pick the proper behavior for the task that you're looking to accomplish with Gamesalad and moving objects and rotating them and other such elements. So one of the first things that we're going to go ahead and look at would be gravity. So that's one of the main things that we can do in Gamesalad. Now, we don't always use gravity. There are other ways that we can get a little more control over things by simulating gravity, and we'll look at that later on. But for right now, we're just going to look at this main gravity feature. So I'm going to go ahead and by default, gravities are all set to 0. So we're going to go back and we're going to look at, I'm going to drag an actor in here, this player actor that I've created here. And we'll go ahead and just open them up. And we're going to look at one key aspect of an actor to get started. And that's this, under the physics tab, is this movable checkbox. So now movable, this checkbox basically turns an actor or assigns an actor into the physics engine. If the checkbox is off, then the actor becomes no longer movable and it will not respond to any of the physics behaviors that we use in Gamesalad. So we'll look at the behaviors later that are related to the physics engine, but for right now I just want you to focus on this movable aspect. So if we uncheck movable, it removes the actor from the physics engine. So if we're to come over here and apply a gravity to our scene on the Y value, so 100, which will be pulling everything down our scene. And so I have this actor on the scene, and I've unchecked the movable. So if we were to hit preview, nothing's going to happen. The actor is just going to stay in this position because we've pulled it out of the physics engine. We've told the actor essentially not to respond to any commands that come through our physics. So let's go ahead back in to our actor, and we'll go ahead and we'll check movable, and we'll hit preview. And so now what we're going to see is our actor is now being pulled down by the force of gravity. It's being affected by the physics engine by checking it movable and unmovable. And we can also come up and we could apply a gravity on the X position. So it's now going to pull our actor this way. And if we wanted to have a negative gravity to go the other way, we would just put a minus sign in front of the number that we put in there. And so now if we hit preview, it's going to pull our actor the other way. And same for the Y. If we want to go up, it's negative values up and it's positive values down. It's positive values to the left and negative values to the right. And that's basically what we do with gravity and setting the gravity world. So once we set gravity in our scene, it's going to affect every actor that is movable. And any actor that is not movable will not be affected by the gravity engine. So now there are pros and cons to using gravity. A lot of people in Gamesalad choose not to use gravity. I like to use gravity for very specific instances where I want to have a natural kind of effects with gravity, with bouncing and things kind of moving around to let the friction and the density and all those things kind of create this randomness of movement in particular games. And it also helps for particular instances to really slim down your code because you don't have to worry about which direction things are moving in a controlled manner. You can kind of let those things happen on their own and adjust your own little physics world. There are certainly advantages to that, and it really depends on the type of game that you're building. For most of us, when we're doing more like a platformer type game, we really want more of a controlled environment. We want to be able to control the player's movement up or down, left and right, and not have to go through because there are ways to move actors on a scene with gravity when movable is unchecked. But then that adds layers of other issues that go along with that as well, because anytime we move an unmovable actor using behaviors like interpolate or change attributes or even constrain attributes, we're basically overriding, or we're outside the physics engine. So we're kind of merging two worlds there, which can cause issues. You have your actors that are part of the physics engine, and then you have these other actors and things that you're trying to interact with that aren't part of the physics engine, and you have to kind of code around those things, and it makes it a little tricky. So there are a lot of different ways to use the physics engine. So let's just go ahead and we're just going to take a quick look. I've stacked all the different behaviors in here in this group that we can just take a quick look at that are related to the physics engine. So as we've seen over here, we have this movable checkbox that when we check, it's movable. And so when an actor is movable, it will respond to any one of these behaviors that I have present on the scene. And other than this one, the collide behavior, which you can put into non-movable actors, because any actor that we have in our scenes, we have to tell the physics aspect or the actors that they're collidable with each other. Because sometimes we want actors to ignore other actors, and then sometimes we want them to collide. So we have to tell the engine, which actors are going to be interacting with each other in that world. So, but other than this one behavior, all these other behaviors can only be used when movable is checked in an actor. You don't have to be using gravity, but you do have to have movable checked, which puts it into the physics engine. And all these particular behaviors here are all aspects, or all use the physics engine to get their parameters and execute them. So we have the basic accelerate. We have an accelerate behavior. And now accelerate's a little different from speed. We see we have acceleration here, and then in a change velocity we have speed, and in these move to behaviors and these rotate behaviors you're going to see speed. Well, there's a reason why that's categorized that way, because speed is more of a consistent moving. So if you set a speed to 300, the odds of that actor is under a control. Now it will still bounce off of things and can get increased velocity from a reaction like that, from a bounce, or even from friction can slow its speed down somewhat. But an acceleration is more like throwing a baseball or putting up a basketball or launching some kind of object where you don't really necessarily have control of the object after you've set it into motion. And so under accelerate, if you put an accelerate behavior, for example, and you say you put a wrapping on there or whatever, and you just let that actor keep kind of moving and moving, it can gain speed, it can gain acceleration, because you're really not controlling it. Whereas if you put an actor on a scene under a move to, or a move in a particular direction, and you put wrapping on there and you put the speed on that, when it doesn't interact with anything, it's going to stay at that. It won't change from that speed of 300. So accelerate is more of a less controlled, less controlled velocity using that behavior than a speed behavior, like move or move to, or rotate to angle, etc. And there are ways that we will use accelerate because it's just a real quick behavior that we want to have a natural velocity and trajectory to something, like in a cannon-fired game, bullets, things like that, where we want the actor to kind of move in a natural manner, gaining that acceleration over time. Whereas if we use a change velocity or a move to, the actor's going to acclimate that speed right away. It's going to start at 300, where accelerate, it's more going to kind of ramp up over a little bit of time and really respond to the different aspects of the physics, friction, things like that. And the same thing with accelerate towards is very similar, except that we can pick a position that we want to have something accelerate towards. So we would use this behavior, say if you were you know, I've used it before in a tank game where, you know, I want the tank to fire with maybe an automated system. Maybe you have, you know, computer controlled guns on like a tower defense type game or whatever, and you want them to kind of be able to know whereabouts the enemies are and shoot. And usually what you'll do is you'll put like a random, you'll put the position of the targets, but then you'll add a randomness to it, so it kind of looks like hit and miss. There's kind of a natural human factor in there. Using accelerate is one way to use and accelerate towards. And let's just go over one thing real quick in relation to these behaviors in the sense of this relative to. So we can do any type of movement or such in two ways. We can do it in relationship to or relative to the actor, and we can also choose to do it relative to the scene. And this becomes critical, and I think some people might miss this, because let me show you exactly what I mean. Inherently in an actor in Gamesalad, when you drop a new actor on the scene, it comes in like this. It's the default position, which just so happens to line up with the way the scene is laid out. So we have a particular, this little handle right here, okay, tells you the facing direction of the rotation or the scene in relationship to an actor, and that just happens to default to be the same as the scene. So this little handle points in this direction, so we're going to see 0 in relative to rotation or direction is this right hand side of an actor, just the same way this handle that we use to adjust rotation is pointing. And so when we select relative to actor, we're going to say do the direction in relationship to the actor's rotation, not to the scene. So if we came in, let's say, and we changed the actor's rotation to 90 degrees, and we come back down in Gamesalad, we're going to see that 90 degrees is now in this direction. Okay, so if we go ahead and we say we had a setup where, okay, we want this actor to move down, but we've rotated the actor. So if we came in and we said, let's go, let me turn all these other behaviors. Oh, I'll just drag it outside. This is the easiest way and keep everything. So let's say, you know, we would like our direction to go down, which is 270. So, but we set it to relative to actor at a certain acceleration. So let's just look at the scene for a minute. So it's the same way in the scene. So the direction on a scene is 0, okay, is going to be straight across to the right hand side. 90 degrees is going to be straight up. 180 degrees is going to be straight left. And 270 degrees is going to be straight down, and then everything else fills in on the appropriate angles. But that's how it works. It goes counterclockwise in its numerical value. So if we were going to set this actor, and let's say we had rotated it and we put it in, we want it to go down like we just set it, but we set it relative to actor. Let's look and see what's going to happen. Oh, I'm sorry. I need to shut off that gravity. Let's get rid of that. Okay, so what's going to happen is now our actor is going to move different. It's not moving in the direction that we wanted it to. It's moving actually 270 degrees in relationship to the actor. So if we look at this, this is 0, 90, 180, 270. So now its movement is relative to the actor. So it's relative to the actor's rotation, and then it's going to move in that direction, leading in that direction, depending on the way the actor's facing. So now that can be handy when you want to do certain things, but if you want to keep all your actors in sync together, if basically your goal is using an accelerate behavior to simulate gravity, which would be a force pulling down at 270 degrees. And this way, if you're simulating gravity, then you really don't have to worry about, you can still have an actor movable, and it can be movable without having you to worry about it counteracting the world gravity, which is what we set up there in those attributes. It makes it a little bit easier in the sense of having to worry about less things, and you can have everything in your collision world with doing less coding of worrying about holding actors in place until they interact or they move, which is what happens when we have a complete gravity world. And so we need to just make sure that we set it to the appropriate relationship, whether we want it relative to an actor and to a scene. And then so we have the change velocity, which basically what we can do is when an actor is moving, we've set it into a velocity, we can go ahead and trigger this and then change its velocity based on certain conditions. And then we have the collide behavior, which is very simple. You can make it collide with a specific actor, or if you use tags, you can just group everything together. So if you have your hero and everything in your world that is collidable, whether it be a bridge or a platform or a ladder or whatever kind of things that you're doing, the ground and such, you can just group all those into one tag, and then say, in your main hero, you can say, yes, collide with everything under this tag that I've named it. It makes it a lot easier. Instead of having tons of these collide behaviors in there, the easiest way is just to tag them that way. And then we also have the move behavior, which basically sets our actor into a moving based on simply a direction, using a speed, which, like I said, is a little more constant than an accelerate behavior as it goes whichever way. And then we have the same thing here. The same applies with the relative to actor and to scene as to direction. So now in the move to behaviors, we also have this other little move type, okay, which is additive and stacked. Okay, so as we see, what happens is in additive, when we have two types of behaviors, so let's say we have a move to behavior in this direction, and when it reaches a certain point, we want to move in another direction. So one of the best examples would be if you're using, let's just use for example, arrow keys. And using arrow keys, and you have, the arrow keys tell your actor to move at a certain speed. So you'd have 4 move behaviors. And it would say, when left key is down, move to the left. When the right key is down, move to the right. When the down key is down, move this way. When the up key is up, move up. And the thing is so say we want like lateral or angular direction as well for our player. What we do is if we use the additive, in other words, if we take the up and downs and the left and rights, and we use additive, what's going to happen is if we were to press both the right key and the down key, that's going to add the 2 directions and the 2 velocities together and actually put our character on more of an angular movement together instead of more of a linear, moving straight to the left, moving straight down. It's going to combine those values, those velocities, and give us an average and add them together. And so you'll have more of an in-between movement in between your clock. So if it's you're moving to the left, which would be 3 o'clock, and then you're down, which is 6 o'clock, it's going to move you somewhere in between 4 and 5 o'clock. So it's going to give you more of that angular direction, which is what additive means. And then the move to behavior is basically we're going to move to a specific position on the scene at a constant speed, as we've discussed. And then we have our basic rotate behavior, which we can rotate around the center of an object, the center position. So our rotation is factored on this circle right here in the center position, and it's going to rotate around that position. There are ways to code that out, and Gamesalad has just announced that they're adding a offset into the system, so now we'll be able to offset our rotations. But for right now, as I'm making this video, everything works off the center, and there's code that snippets on the forums that'll show you how to do rotation offsets. And then we have rotate to angle, so we can tell our actor a specific angle. We want you to rotate to this angle. And then we can say, run to completion or stops on destination. The same with the move to, run to completion, which means it'll keep going. Even if it hits something or whatever, it'll keep running to that position. So it'll kind of move around an object if its surface allows it and the contact allows it to kind of go around and keep getting to that position. And same down here, stops on destination or doesn't stop on destination, so we can start an object rotating to a specific angle. And rotate to position will basically rotate an angle, rotate a thing, almost like an arrow, like a speedometer or something. If you say, rotate to this position, X and Y, and then you can set an offset angle, and that's basically where it starts from. So if you set up an actor and you wanted it to start 10 degrees off, like almost like a bias, you can do that, and the speed at which it moves and relative to scene or actor, run to completion, and stops on destination. So these are the basic behaviors that we use in the system for physics to be able to make our actors move around and respond in more of a natural kind of way than just kind of force moving them, and allows us to do more of simulations in relationship to the density and friction and bounciness and drag and all that kind of stuff in our games. And so in the next video, we'll start going through some of these physics attributes here and how they work and what they mean and what can be applied and what can't be applied in Gamesalad. And we'll go on through starting to show you how different things, when they mix together, the different things you can run into. Because when you start getting into the physics engine, things can tend to, it's difficult to kind of control things because you're dealing with real physics in front of bumping into objects and then moving out of position, and all those kinds of issues come. And I'm going to start to show you some different ways that techniques that you can apply when using physics in Gamesalad to overcome and work around, not so much work around, but overcome and deal with some of these little nuances and little issues that we have. And it really depends on the type of game you're building and what you're trying to do. So I just want to give you a handful of different techniques that you can start to pick and choose from and see how you overcome specific issues when you're dealing with the physics engine. So this is Dave the Guru, and I'll see you in our next video.